Okay, so welcome back to our last discussion for Chapter 4. Ibig sabihin, after you watch this, midterm exam na. Let's talk about this topic. So, solubility equilibria. So, what can you notice with the given chemicals in there? Silver chloride, magnesium fluoride, silver carbonate, calcium phosphate. What can you notice about them? They are solids. Okay. And to be more specific, we call them precipitates, right? We call these things precipitates. However, look at what happens to our precipitates. The solid gets equilibrated into aqueous species. No? Ibig sabihin pala, yung mga precipitates natin, let's say this is a whole precipitate, portion of them turn into aqueous. Pero process is actually that is actually reversible. Okay, so some of the ions may get dislodged sa solid and then sometimes they return. Okay? So ganun pala, no? So kaya ito yung pinaka reason why we call our precipitates the sparingly soluble substances, no? Sparingly meaning super onti lang nang na-dissociate into ions. Okay? So that's the idea in the solubility equilibria. Okay? So that your precipitates are not really that insoluble. Okay? They are not really solid. They somehow turn into ions. Okay? But to a very tiny extent only. And since it is governed by an equilibrium arrow, okay, or by equilibrium concept, meaning we have a k value here. Okay? We have an equilibrium constant, and that equilibrium constant is called the KSP, or the solubility product constant. So basically, KSP is just the product of the solubility process. Okay? Yan. So, itong mga products lang yung sinusulat natin. Because of course, your reactants are all solid. You don't have to write them. So, yung products lang nilalagay. Kaya nga solubility products tawag dyan. Okay? And of course, yung KSP, it has a value. Okay? Just remember, the greater the value of your KSP, the more soluble it is. But look at our precipitates. Look at their KSP. Grabe ang liliit ng kanilang KSP, no? So look at this, is negative 33, negative 72, negative 26, 29. So ganun sila ka-insoluble. Pero still, some of them will still turn into ions. Pero just a very, very tiny amount, no? So yun yung idea, no? That precipitates are not really that solid. They turn into ions, but the extent is very tiny lang, no? So, masyadong maliit lang yung chance for them to turn into precipitates. Okay? And their equilibrium constant is called the KSP, or the solubility product, for the plain reason that yung products lang yung nandun sa K expression natin. Yung product ng solubility, yun yung nandun sa K expression. Okay? So actually, itong topic na to, this is just a very easy topic. Okay? Compared to acid-base na maraming ginawa. Ito, mabilisan lang to. No? So, these are the common things that you have to remember when it comes to solubility equilibria. We have this term called molar solubility. So basically, it tells you the number of moles your precipitate can be dissolved in a liter of a solution. And the solubility, which is not in terms of moles, but rather in terms of grams. Okay? And then commonly, the problems here will just ask you to convert the molar solubility or to convert solubility to molar solubility. And then sometimes you need to convert them into KSP and vice versa. Okay? So, ganun yung mga common problems dito. So, you will be given a solubility to molar solubility, and then later you convert it into KSP. Or sometimes yung KSP, you have to convert it into molar solubility, then finally into solubility. Since we are already familiar with equilibrium, so madali na lang to. Okay? We will still use ice table, but the ice table here will be very much reduced. Okay, and I will show you in this problem. Okay, so kunwari, ito tanong, what is the solubility of silver chloride in grams per liter? Okay, wala. Yun lang yung tanong. What's the solubility of silver chloride in grams per liter? So, in order for you to answer this, we will just refer to this illustration here. If hinahanap ang solubility of a compound, what do you need? You have to look for its KSP. Okay? So, the KSP is shown here, no, yung kaninang pinakita ko. So, we can just look at the KSP of our silver chloride. So, nasa silver chloride. Ayan. So, this one is silver chloride and its KSP is 1.6 times 10 raised to negative 10. Okay? 1.6 times 10 raised to negative 10. So, that's the value of its KSP. Now, gagawin natin, so from our KSP, we have to convert it into the concentration of cation and anions, the molar solubility of the compound, and the solubility of the compound. Okay? So, ngayon, the question is, how will you convert the KSP into concentrations? Kanina pa natin ginagawa to. Ice table. Okay? So, we need to employ the ice table so that we can get the concentrations of our ions, the products. And then, kung ano yung value ng X na yun, that's the molar solubility. And that will give us the solubility of the compound. Okay? Let's try this one. So, what's the solubility of silver chloride in grams per liter? So, first you have to show the solubility equilibria of silver chloride. So, you just write AgCl. So, it is solid, of course, it's a precipitate. And you show that it equilibrates in silver ion and your chloride anion. By the way, ito, request ko lang, kailangan alam nyo na yung charges ng ions. Okay? So, you must know the charges of your ions. So, as you can see, for silver chloride, solid yan. So, we'll just skip this column. Okay, so, blank lang yung column na yan. This is solid eh. And then for the products, we don't have any concentration of that, right? So, ibig sabihin, we don't have initial concentration for silver, we don't have initial concentration for chloride. Meaning that in order for us to achieve equilibrium, what needs to be done is to what? Ang kailangan natin gawin ay mag-produce ng product. Okay? So, kung nasa yung 0, dun yung positive change. So, that will be positive X for Ag, positive X for silver. So, meaning at equilibrium, we have X concentration for silver and X concentration for chloride. Okay? And yan na yung equilibrium concentration na sinasabi dito. Okay? So, that's the concentration of cations and the anions. So, X and X. So, now, we need to solve for the X, of course. No? So, you just write the KSP. Okay? This is your equilibrium reaction. So, you write Ag plus and then Cl minus. And then yung AgCl, you don't need to write it because it is solid. What's the KSP? Ayun. So, it is 1.6 times 10 raised to negative 10. What's the concentration of Ag? That is X. What's the concentration of Cl? That is also X. So, X times X is X squared. That is 1.6 times 10 raised to negative 10. All you need to do is to just get the square root of both sides to get the X. Okay? Then, upon getting the X, okay, pag nakuha mo na yung X, okay, let me just type it. 1.6 times 10 raised to negative 10. Okay, so this is the value of x, so it's 1.26 times 10 raised to negative 5. So what is this? Ano tong x na to? This is actually the molar solubility. So kung ano yung x mo, yan ay molar solubility. Diba? Napaka-straightforward lang ng topic na to. And this is your molar solubility na. Okay, so ganun siya ka-straightforward. Okay, so basically, solve ka lang kung ano yung x mo, yan ay molar solubility. Easy. I will write it in moles per liter. Now, the question is not molar solubility. Instead, we are asked about the solubility lang. And again, the solubility is grams per liter. So we need to find a way wherein this molar solubility can be converted into grams per liter. Ano gagawin natin? So actually, if you multiply the molar solubility by the molar mass, you will get the solubility lang. Okay? So ito yung typical process dito. So if you got the molar solubility, you want to get it, you want to convert it into just solubility, you multiply everything by the molar mass lang. So that's simple lang. So let me demonstrate to you how to do it. Okay, so it's 1.26 times 10 raised to negative 5 mole per liter. And then you get the molar mass of your precipitate, silver chloride. Okay, so i-google natin. Okay, molar mass silver chloride, AgCl, 143.32. So you just need to multiply it, no? 143.32. Tama ba? Okay, tama. Okay, so when we multiply our molar solubility by the molar mass, you can see that the moles will cancel out. Okay, so you get the grams per liter na talaga. Okay, multiply everything by 143.32, and this is our solubility, 1.81 times 10 raised to negative 3. Okay, so ganun lang yung problem dito. Okay, so you will be given the KSP, and then you need to look for the solubility, okay, the molar solubility. Yan, so that's simple lang. Or sometimes you have to do the reverse process. You will be given the solubility, then you convert it into your KSP. So madali lang naman siya compared to acid and bases, no? So actually, we can do some shortcuts here. Okay, so for example, AgCl, the KSP expression is just Ag plus and Cl minus. We can represent our Ag as concentration S, and for the anion, it's also S. So for you to get the value of S, you just need to get the square root of the KSP. Okay. However, if the ratio of your cation and your anion is 2-to-1 ratio, ito, puro 1-to-1 yan. If 1-to-1 yung ratio, it's just this, S is the square root of KSP. Okay. Yung S nyo is the molar solubility. Molar solubility. Nandun na pala. However, if the ratio of your cation and your anion is 2-to-1 or 1-to-2, the equation for the molar solubility will be the cube root of your KSP divided by 4. Let's explain how did that happen. Okay, suppose if your ice table shows 2x and then another x, okay, yung isa dyan may coefficient na to kunwari, that will give you 2x squared times x, no, in the KSP. Na-imagine nyo ba? So if hindi, ganito. Punta tayo dito. Kunwari lang. Kunwari, you have your 2 here, no? 2 to 1 yung ratio nila. So meaning this one will be 2x. Okay, and then when you write it in the KSP, that becomes AG squared CL1. Okay, and then the 2x dito yan, then magiging square, and then this one will be x. So this becomes 4x squared times x. So it becomes 4x cubed. Okay. If you rewrite this KSP 4x cubed, no, to get the x, that's just the cube root of KSP divided by 4. Okay? So yun yung pinaka-point ko earlier. So yan, if the ratio of your ions are 2 to 1 or 1 to 2, so dalawang cation or dalawang anion and the products, then to get the molar solubility, that's as simple as the cube root of KSP divided by 4. And if yan ay 3 to 1 yung ratio, if the ratio is 3 to 1, then to get the S, that's just the fourth root, no, of KSP divided by 27. And lastly, if that's 3 to 2 ratio, that's S equals the fifth root of your KSP divided by 108. You can use this table if tinatamad kayo mag-ice table. Okay? But, you know, ice table is very convenient naman. And it's very easy to make. So it's up to you whether you're going to use this or just rely on your ice table. Okay? Anyway, so what else can this tell us? Okay? So this solubility equilibria can tell us whether we will form a precipitate or not. Pwede niya sabihin kung magkaka-precipitate ka o hindi. Okay? So, kailan ka magkaka-precipitate daw? When your Q is greater than the KSP. What is Q again? That is your reaction quotient. Okay? So if the reaction quotient is greater than the KSP value, then you will form a precipitate. But other than that, no precipitates can be observed. So, ang galing, no? Ibig sabihin pala, hindi porket pinaghalo mo yung dalawa, may precipitate na mabubuo. Not really pala. There will come to a point wherein they will start forming the precipitate. So let's try this problem here. If you have 2 ml of 0.2 molar sodium hydroxide added to 1 liter of 0.1 molar calcium chloride, will a precipitate be formed? No? So pinaghalo mo daw yung mga substance na yan. Tapos may mabubuo bang precipitate? So, first thing, you have to know the equation. Ano ba mangyayari? Okay, so our sodium hydroxide can react with calcium chloride to produce what? Calcium hydroxide and sodium chloride. Okay, so this is the correct equation. Sir, saan mo nakuha yan? Basically, kailangan alam nyo yung solubility rules. What I know is that the calcium will form precipitate with hydroxide. So again, kailangan mabilis na kayo sa solubility rules. Okay? But don't worry, I think ibibigay naman sa quiz yung equations na mismo. But if hindi given, then that means you really have to focus on whether kaya nyo ba mag-isip ng equations real quick. Okay? So if kaya, then that's good. So this is the precipitate na. Ibig sabihin, pwede pala mag-form tayo ng precipitate. Okay. So now, ano gagawin natin? So, what we're going to do is this one. Okay? So, you know that your calcium hydroxide will be the precipitate. So, siya yung lalagay mo dito. Na? So, what will it produce? It will produce calcium 2 plus and 2 OH anions. Okay? So, let's look at the initial concentrations. Okay? May binigay na tayo na initial amounts. Okay? So, ano yung initial amounts? For hydroxide, ito. And then for chlorides, ito. Okay? So, paano natin siya gagawing concentration? Okay, so basically, this is another dilution process, just like in acid-base equilibrium. So if you're going to mix two substances with different molarities and different volume, they tend to get diluted. Okay, so we need to show the dilution of our sodium hydroxide and the dilution of calcium chloride. So ipakita natin. So remember, in the dilution equation is C1 V1 equals C2 V2. We want to get the final concentration, so that will be C1 V1 over V2. So for the dilution of sodium hydroxide, its initial concentration is 0.2 molar times the the V1, which is 2 ml, and then the volume, which is the final volume pala. Now the final volume is the sum of this volume and that volume. Basically, it's 1.002 liters. So, ano yung dilution niya? Tignan natin. Yung mga diluted concentration niya. So, the diluted concentration will be 0.2 times 2 ml divided by, ml and liters pala to. So, I have to convert this into ml. Divided by 1,002. So, ito na yung diluted concentration. Okay, so 3.99 times 10 raised to negative 4. And then for calcium chloride, ganun din. Okay. So for calcium chloride, you have 1 liter. So the initial concentration is 0.1 molar times 1 liter. 1,000 ml divided by the sum of the volume, which is 1,002 ml. So let's check the diluted molarity. So that will be 0.1 times 1,000 divided by 1,002 ml. So the new molarity is 0.99. Okay, basically, we can just round it up na lang. Okay? So it is still 1 molar. 0.1 molar. Okay? So now, ano gagawin natin? So actually, these are your initial concentrations, right? Okay? Ito yung mga initial concentration mo. For the OH, ito yung initial concentration. And for the chloride, for the calcium, ito din yung initial concentration mo. So meaning we can plug it into our Q. Okay, so again, Q is just the reaction quotient, no? And basically, itong ions natin na to, plug in lang natin sa Q. So that is the concentration of your calcium initially times the concentration of your OH initially, then squared because of the coefficient na 2 doon. Okay? So plug in natin. So for the concentration of calcium, that's 0.1. For the concentration of OH, that's 3.99 times 10 raised to negative 4. Then square natin yan. So what's the reaction quotient? So the reaction quotient is, so it's 3.99 times 10 raised to negative 4 squared. Okay. So the reaction quotient is 1.59 times 10 raised to negative 8. So 1.59 times 10 raised to negative 8. So in order for us to tell whether a precipitate will form or not, we need to compare the Q with the K. Okay. So ano yung K ng calcium hydroxide? Tingin tayo sa table kanina. Okay, so for calcium hydroxide, the K is 8 times 10 raised to negative 6. Okay. So that's 8 times 10 raised to negative 6. So the question here is, will you form a precipitate or not? So we can say that the Q is less than the K. So what will happen? If your Q is less than the K, then you will form no precipitate. Okay? So there will be no precipitate. So meaning super onti lang ng iyong ions na that they are not enough to form the precipitate. Okay? So ganun lang. Another type of problem here is that you will need to know what is the minimum concentration for you to precipitate out one ion. Okay? So let's look at this problem. What concentration of silver is required to precipitate only silver bromide in a solution that contains both bromide and chloride ions of 0.02 molar? Okay? So yan yung pinaka-question sa atin. Okay? So basically, ganito lang gagawin ninyo. Tinatanong is the concentration of silver if your bromide or chloride ion is 0.02 molar. Okay? So hanapin mo daw yung concentration ng silver kung given na yung concentration ng bromide and the chloride. Okay? So what precipitates can be formed when we react this with the two ions? So of course, we can create silver bromide precipitate and silver chloride precipitate. And this can dissociate into ions, so silver ion and chloride anion. This one can do the same. But this will dissociate into silver ion and bromide ion. Tas ano sabi? The concentration of the ions, no, yung halides natin, 0.02 molar. The question is, ano yung concentration ng silver? Okay? So, ano yung concentration ng silver so that they can form? So, we can answer that using KSP. Okay? So, the KSP for this equation is Ag plus Br minus. For this reaction here, it's KSP equals Ag plus and Cl minus. We want to know the concentration of silver. So we need to get the ratio of KSP and the halogen. So Ag plus is the KSP over the Br. Same with this one. Ag plus is our KSP divided by the Cl minus. So ipa-plug in na lang natin yung KSP values. Okay. For silver bromide, ano yung KSP value? I don't know. Silver bromide. Okay, so for silver bromide, that's 7.7 times 10 raised to negative 3. 13. Ayan, 7.7 times 10 raised to negative 13. So it's 7.7 times 10 raised to negative 13. And the concentration of bromide was said to be 0.02. So what is the minimum concentration of silver so that we can form the bromide? Okay. So that will be 7.7 times 10 raised to negative 13 divided by 0.02. So yan. So 3.85 times 10 raised to negative 11. So basically, if you have this concentration of silver, the bromides can start precipitating. Pwede na siya mag-precipitate. But the goal here is that may dalawa kang ion sa solution. You have silver bromide and silver chloride. Ayaw mo mabuo yung chloride. Gusto mo lang mabuo is the bromide. Diba ito yung minimum? Let's find the maximum amount of silver before the silver chloride can form. Okay? So we can calculate for that using this equation. Okay? So for the silver chloride, ang kanyang KSPI. So for silver chloride, that's 1.6 times 10 raised to negative 10. And the chloride concentration is said to be 0.02. Ito yung pinaka-maximum limit. Okay? So it will be 1.6 times 10 raised to negative 10 divided by 0.02, 8 times 10 raised to negative 9. Okay? So, ibig sabihin, in order for us to precipitate only the silver bromide in the mixture of bromide and chloride and ion, the minimum concentration of silver should be this, no? So 3.85 times 10 raised to negative 11 molar. But the maximum concentration of silver should be this one. So ibig sabihin, if you want to precipitate only the AgBr, you have to add silver chloride concentration that is within the range of 3.85 times 10 raised to negative 11, okay, but will not exceed 8 times 10 raised to negative 9. So ito yung mga allowed values for the precipitation of the silver. If you exceed this, silver chloride will form. Okay? Exceeding this will form AgCl, which we don't like. So, ibig sabihin, kapag mag-add ka ng silver, it must be just within this range. Okay? If you exceed that, wala na. Pangit na yung results. And don't worry, walang ganito sa quiz. Walang ganito sa quiz. We just added this in the PowerPoint so that you can see the applications, okay, of solubility equilibria. Diba, remember, in doing chemical analysis, no, we should be able to separate our ions. Ganito yung ginagawa. Okay, so let's suppose you have a mixture of different ions and you just want to select one of them. So you can do this. No? So tawag dito selective precipitation or differential precipitation. Parang ganun. So, hindi mo is-precipitate lahat because if you precipitated everything, mahirap. No? Mahirap malaman kung sino yung sila. Okay? So, again, wala na ito sa quiz. We just added this so that you can see yung applications of precipitation gravimetry. Okay, and then for the last one, okay, meron na ito sa ating worksheets. Now, I will post the worksheet for the laboratory. Okay. Sorry. So, hindi po pala to last one. So, let's talk about the common ion effect and the solubility. What is a common ion? And what is its effect in equilibrium? When I say common ion, basically, you have an ion that exists in equilibrium with the precipitate. Yung sabihin, meron ka ng ion na same yung ions nila. Okay. So what will happen? So parang lang doon Le Chatelier principle. If meron ka ng existing ion then you don't really need to produce products anymore. Okay? Kapag may existing product ka na, you don't really need to put much effort. Okay? Hindi mo na kailangan masyado mag-effort. Okay? So, ibig sabihin, if you have common ion, it decreases the solubility of the salt because it doesn't need to dissolve that much anymore to achieve equilibrium because may existing ion na eh. So, for us to visualize further, I'll answer this problem. Okay? And then, check natin what will be the effect with sodium bromide. Okay? So, silver bromide is a precipitate with this dissociation process. Okay? So, in water, so in pure water muna tayo, of course, there will be no concentration of the products. Okay? So, wala tayong concentration ng products, so we can just simply solve for the solubility, no? So that's KSP equals x squared. Get the solubility, that's just the square root of KSP. Paano naging x squared yan, sir? Ag times Br. Okay? So in pure water, that is just x equals the square root of the KSP of the AgBr, no? Which is what? Ano ba yung KSP ng AgBr? 7.7 times 10 raised to negative 13. So 8.77 times 10 raised to negative 7. So ganun lang yung kanyang solubility. 8.77 times 10 raised to negative 7 molar. Okay. The question is, how about in the presence of a common ion? Pag sinabi natin common ion, ibig sabihin may ion siya nakaparehas sa ating equilibrium. In this case, yung sodium bromide, it can dissociate into sodium ion and bromide anion. And as you can see, the bromide anion is the same as the one in equilibrium, right? So, ano mangyayari? So, ibig sabihin, yung initial concentration natin ng Br is no longer 0. Rather, it's 0.001. Okay? You can use stoichiometry to get the molarity of the bromide ion. So, hindi na siya 0. Rather, it's 0.001. So, magbabago yung ating equilibrium expression. So, meaning, may Le Chatelier principle. Right? So, if you try to get the value of the molar solubility, the value of x, we can write it this way. Okay? So, we have x here, and then for the BR, that will be 0.01 plus x. And as you can see, magko-quadratic tayo dito. So, we don't have a choice. Okay? So, lipat ko to dito. That would be 0.01. Sorry, dalawang 0 pala. Minus KSP. Okay? So, this is how you do it with algebra. Okay, so x squared plus 0.001x. Okay, and then using our algebra function in the calculator, ano yung makukuha kong x? By the way, if you can notice, medyo mabilis lang discussion ko dito kasi onti lang yung ganito sa quiz and exam. More focused tayo sa acids and bases. Okay? Okay? So this is the first root, 7.7 times 10 raised to negative 10 molar. And then the second root is negative. Of course, we will discard the negative, we'll accept the positive root. So, di ba, nakita nyo that the molar solubility was reduced significantly. Originally, without the common ion, the solubility of AgBr is this 8.77 times 10 raised to negative 7. But in the presence of 0.001 molar sodium bromide, its solubility was further decreased to 7.7 times 10 raised to negative 10, confirming that the presence of common ion decreases the solubility. Ito yung sinasabi ko kanina na kapag may product na, you don't really have to put effort anymore. 'Di ba? Parang, parang sa ano lang yan eh. Parang sa class lang yan. Pag may sagot na si classmate, medyo hindi ka na mag-effort kasi mangungopia ka. Pero bad yan. So you don't really put that much effort if the material is already existing. Right? So ganun din sa precipitation or in the common ion effect. Okay? So yan. Okay. And then lastly, okay, last na to. The pH can also affect the solubility of a substance. The presence of common ion decreases the solubility, we all know that. And if you have an insoluble base, it will be dissolved in acidic solution. And if you have an insoluble acid, then it will dissolve in basic solution. What if you put your insoluble base in a basic solution? Then it will not dissolve that much. Kapag yung insoluble acid nilagay mo sa acid na in acid solution, edi hindi rin siya madidissolve. Okay? So that's the effect of pH and the solubility of our precipitates. So this will be the last problem. Okay. So let us try to consider the magnesium hydroxide in acidic and basic solutions. Okay. So basically, pag ganyan yung question, I just ask you, what is the pH? Okay. What's the pH of the magnesium hydroxide solution? Pag ganyan yung question, ayan lang yung hinahanap. What's the pH of magnesium hydroxide solution? So, you just copy the equation written here. So, you have your magnesium hydroxide that's in equilibrium with magnesium 2 plus and 2 moles of hydroxide and ions. So, wala naman sinabing initial concentration, so those are 0. The change is x for magnesium and 2x for the OH. Keep in mind the coefficient has to be considered. And at equilibrium, that will be x and 2x respectively. So, in order for us to get the pH, we have to know first the concentration of OH. Okay, so we can use KSP to get the value of x and then the OH concentration. So for magnesium hydroxide, the KSP can be written as Mg2 plus and OH minus squared. Okay. So magnesium concentration is X. Then for OH, that's 2X, then squared. So that meaning that's X times 4X squared or 4X cubed, right? So to get the value of X, all we need to do is to divide KSP by 4 and get the cube root. And so the KSP is given. It's 1.2 times 10 raised to negative 11 divided by 4. So we'll get the value of X. Okay, so let's clear this up. So we just need to get the cube root of 1.2 times 10 raised to negative 11 divided by 4. So this is the molar solubility. So 1.44 times 10 raised to negative 4. Now, we want to determine the concentration of the OH. So to get the concentration of OH, that's 2x, right? And 2x siya. So we need to multiply the x by 2 to get the concentration of OH, which gives us 2.88 times 10 raised to negative 4. And now, from the OH, we can use negative log of it to get the POH. Okay, so we can get the negative log of this one. So the POH is 3.54. And if you want to get the pH, that's 14 minus POH. It's 14 minus the POH, which is 10.46. So what does that mean? Okay. So our magnesium hydroxide will be more soluble in pH less than 10.46. Why? Magnesium hydroxide is an insoluble base, and it will dissolve in acidic solutions, meaning that if you have a pH less than 10.46, then it will be more soluble. Okay? So that's our conclusion. pH less than 10.46 will cause your magnesium hydroxide to be more soluble. Okay? So mas magiging soluble siya. But at pH greater than 10.46, it will be less soluble due to common ion effect. Masyado na maraming OH. Okay? So, yun. So, basically, that's it, no? And I'm sorry if medyo rushed siya, pero ganun talaga yung topic na to. So, parang dinaanan lang talaga natin siya. Siguro my tip for you is to just memorize uh, how to get the molar solubility. Important yon. And the solubility, yan yung important. Itong direction ng reaction, not really necessary ito. Pati itong mixture na to. Itong common ion effect, this is also important. That's why I have this one in the worksheet. And of course, this pH. No? So, kailangan marunong kayo mag-determine ng pH ng solution. Usually, yung OH yung titignan mo dyan. Okay? Yan. So, basically, that's it. No? That's the end of chapter 4. And I hope you still learned something. And good luck to your upcoming examination and quizzes. Okay? So, we wish you all the best. And let us know if you have problems, and we'll address that. Okay? So, thank you, and we'll see you again next time. Goodbye.